Hello and welcome to the Databricks Architect Zero to Hero series. It's day 2, and today I'll walk you through the story behind Databricks. Before we dive deep into the architecture, components, and technicalities of Databricks in the upcoming videos, it's important for you as aspiring Databricks architect to understand the story behind the Databricks, how it started, why it was created, and what problem it solved that changed the entire data industry. Because once you understand the why, the how becomes easier. So let's step back in and try to understand what Databricks is, not just as a product, but as a company and how it changed the entire data and AI industry and revolutionized the entire data and AI industry. All right, let's get started. So right now, Databricks is valued at $134 billion, and that's huge. And this report is as latest as February 9, 2026. And Databricks right now, or the products from Databricks right now, are consumed by major companies across the globe, or the top firms across the globe that you see on the screen. Firms like Adobe, AT&T, so on and so forth. You can see the list on the screen, and it's not an exhaustive list. And also, the important thing is, the interesting thing here is the time Databricks took to reach the 100 billion valuation mark. Let's do a quick comparison with major technology players in the market right now. So Microsoft, which was founded in 1975, took 23 years to reach $100 billion, and it reached in 1975. And Amazon, founded in 1994, in 2020, in 2015 they reached $100 billion. That means 21 years it took. And Google, founded in 1998, reached $100 billion in 2007, 9 years. And Databricks, founded in 2013, reached the $100 billion in 2024 to 25. So it's relatively, Databricks has relatively, in comparison with Google, took similar amount of time. But when you compare it with other players like Microsoft and Amazon, then it reached that mark real quickly. And remember, Databricks is an enterprise software company. It's not a B2C company. It doesn't sell products for customers. It sells products for major technology players in the market. So that's an important thing here. So what's the secret behind Databricks success? How is it that Databricks was able to reach this phenomenal success in relatively short span of time? Let's check that. Let's find that out. It all dates back to 1980s, 1990s. The challenge at that time, at that point of time, was a data challenge. At that point of time was the proliferation of applications, the growth of applications. With that growth came the problem of data integrity. That means same data appearing in many places with different values. And as you can see on your screen with John Doe example over here. So incorrect and conflicting data causing decision making confusions. And the leaders at that time were finding challenging to take right decision because data was all confusing and all duplicate. Thus, a new architecture approach was needed to find the right data for decision. And that the data warehouse was born. That was a time when data warehouse was born. So what is data warehouse? Data warehouse is a centralized repository to store the right data for better decision making. It is sort of a single trusted source of truth. And this data warehouse was founded or introduced by Bill Inman. So Bill Inman is an American computer scientist recognized by many as a father of the data warehouse. Let's look at the sense of data warehouse. Okay, the goal was the data warehouse acted as a centralized structured reporting for historical analysis. And as I said, the pioneers in this space were Bill Inman and Ralph Kimball. Okay, and how data warehouses work is, let's quickly look at the architecture. So data warehouse would get data ingested into it from different sources like ERP, CRM, finance, and databases within a firm. And ETL pipelines would be used to ingest data, and then this data would then be used for BI and reporting. But the bottleneck was schema on write. That means the schema should be defined before writing the data on the storage. And that was the limitation. It was expensive to scale vertically, incapable of handling unstructured data. This is an important one. Data warehouse only supports the structured data, that is rows and columns. It doesn't support unstructured data like images, videos, so on and so forth. And that was the bottleneck. And when the dot-com bubble emerged and when the internet was launched, the internet broke the warehouse. So schema on write became a liability. It was not an asset, it was an liability. Warehouses required structure before storage, making them too slow and expensive to capture the massive influx of raw data. So with internet, emerged images, videos, so on and so forth, and that really broke the warehouse. So, what was the solution then? Then the solution, another solution that emerged is Hadoop and MapReduce. So it was early 2000s, inspired from Google's GFS and MapReduce system. Hadoop and MapReduce was launched. So this was the shift from expensive monolithic servers to cheap distributed commodity hardware. And that and what it solved is it solved that massive horizontal scalability problem and cost reduction. So it could scale horizontally and with less cost. So that were the strength of MapReduce and Hadoop. Now with this, it also introduced some complexity. It was an extremely complex software or framework, and because of Java based MapReduce jobs were difficult to manage, slow because they only support batch only, and hostile to business analyst. It could only do, I mean, it could not do analysis. So the business users could not use it for analysis, and that was a big liability or a big con of data Hadoop and MapReduce. So so by the time 2010s, another philosophy emerged, and that was store first, ask questions later, or decide the schema later. And that gave birth to the data lake. Okay, so data lake was born, and it was further accelerated. The data lakes were further accelerated, or the adoption of data lake was further accelerated by cloud players like Amazon, Microsoft, and Google Cloud. So philosophy was schema on read, save raw data immediately in any format. Okay, companies would save raw data here in data lake and define the structure only when analyzing it. So you don't need to define the schema right away even before storing. So that was a good thing with data lake. So that was ideal for data science, image storage, and massive archives. But with this, the swamp failure mode emerged. So data lakes could not offer asset transaction. So reliability is low and no governance there. So it was all duplicate data everywhere. And most importantly, uh, as a result was a repository that is powerful but messy. Right? It could save huge amount of data, but it's all messy. The trust dropped. Okay, now comes an interesting time. So 2014, researchers at UC Berkeley University created Apache Spark. So they launched Apache Spark, and the the strengths of Apache Spark were it was 100 times faster than Hadoop, and it supported in-memory, SQL, machine learning, and the computing engine was extremely powerful. So the lingering issues was Spark fixed the speed of processing, but the storage was still unreliable. We could process garbage faster, but it was still garbage. Okay, the compute engine was extremely fast, but the storage was still a problem. Okay, and also, let's throw light on how Spark offered 100 times faster than MapReduce. So a quick note here: Spark keeps data in memory, while MapReduce writes every step into disk. So what would MapReduce would do is any operation, any step it writes onto the disk, and that slows it down. But whereas Spark stores it in memory and would write it only after a certain period of time. So that gave birth to 100 times faster speed, whereas MapReduce was very slow. If you get that question in mind, that how is Spark faster than MapReduce? Okay, now, so far we have compute we have so far 2014 Spark is there, that's extremely powerful compute engine, but data storage is still a problem. So companies were forced to maintain two compatible stacks. BI teams couldn't trust the lake because it's all messy here, duplicates, and data scientists couldn't use the warehouse. The result, data silos. So company were using data warehouse for BI and analytics, whereas they were using data lake for storage. So the ups and downs were data warehouse, high trust, low flexibility, expensive, whereas data lake, low trust, high flexibility, cheap. Okay, now the creators of Spark founded Databricks. That was an amazing thing. So now 2014, the creators of Spark founded Databricks. So Databricks pioneered the lakehouse to unify data science, data engineering, and analytics. Okay, their mission was unify data engineering, data science, and analytics on one platform. The value proposition was eliminates the need for separate systems, provide data warehouse reliability at lake scale, support SQL analytics and machine learning on the same data. So what essentially Databricks did it combined all the various data engineering, data science, and analytics onto one platform, which could do BI, AI, ML, and so on and so forth. So under the hood, Delta Lake. So Delta Lake was is a table format that Databricks uses behind the scenes. Uh, it supports asset transaction, that is atomicity, consistency. I don't. So it supports asset transaction, schema enforcement, metadata handling, and behind the scenes, it would use data lake for storage of its data. So here is the history of problem solving. Uh, Data warehouses, right at the start of this data technology, trusted and structured, but expensive and rigid. Weakness were expensive and rigid. Hadoop strength was scalable and cheap, but weaknesses were complex and slow. Data lake strength was flexible and scalable, but weakness was unreliable. Swamp, Apache Spark, fast processing but storage agnostic, no support for ACID transactions. Then comes the Databricks Lakehouse, unified, reliable, and scalable, and critical weakness none. So the future is unified. You give raw data to Lakehouse platform, and then the output would be BI and AI, business intelligence and artificial intelligence. So in short, data warehouses gave us trust, Hadoop gave us scale, Spark gave us speed. Databricks combine them all to eliminate silos and power the future of AI and analytics. Thank you. Hope this video was helpful. See you in the next video.